Cam. Took a bit of a time so that you could give all the good introductions about me. So thank you. Hello, Melbourne. How are we? Good. So good to be back here, probably third, fourth time in a row. This time at another topic in the AI space. Right? I'm going to ask a quick question. So how many of you attended my talk last year in Melbourne? Okay, great. So for those of you who attended, good news is I'm going to piggyback a few slides from last year, which means this talk is actually an extension of the one that I gave last year, right? So for those of you who didn't, not a problem. Go back to YouTube. It's already up there in the YouTube, I guess, from the last year's recording. You can take a look at it. But I think if you see from how things evolved from last year to this today, what we are doing, the industry has evolved tremendously. Just to give a quick brief, I covered how you could supercharge your automation test using LLM models. It was just integrating with models like Ollama, and if we're using free LLMs and go from it. But here we are today talking about Agentic AI, right? All right, let's get started. Running short of time. So from fastest test to smartest strategies, I want to begin with something that sort of deeply reflected, because this question also came up in the panel discussion, right? Is AI taking my job, or what is it? So I think to me, it's all about it's not about machines replacing human. It's about how much are we augmenting it, right? So how much are we using those technologies to augment our day-to-day life, and specifically in test automation for testers and quality engineers out there in what we are doing day in day out. The AI, right? This isn't just about the tool, right? It's a partner driving with innovation and excellence. Now, a bit of an exercise. I know it's after lunch, so Cam keeps me in an interesting slot every year, after a year. So this time it happens to be post-lunch, and we are waiting for the break. So quick bit of an exercise. How many of you have heard about AI? Silly question, right? I made it purposefully so we can have some giggles. Also, we can see almost AI in all the banners up here as well as in the flow, right? But last year, the response was not overwhelming like today. So that actually itself says how AI has been evolving from the last year to here in just 11 months, 12 months of time. Okay, next question. How many of you have used AI? Now, what I mean by AI here is debatable, but at least whatever you thought of, great. So that means you're already using a bit of an AI, which is already great, right? Now, let's talk about the evolution of software paradigm itself, right? So you can actually see from a traditional programming back in all like 10, 20 years back. Let's not put 10, at least 10 years back, they were a bit of an AI. I'll talk about that evolution a bit. So to where it started to what we are doing right now, it's completely changed the ways of working, right? So in traditional world, you can actually see the computer can perform the task which it was asked to do, and so does the testing of itself as well. So we know 1 + 1 is equal to 2, and that's what we want to test for. Even if it's unit testing, if it's a UI, we do all sorts of testing. So now in the AI world, which is the machine learning models world, it's different. It's probabilistic, right? So what do you test for? So all these questions keeps on coming up. So while the software development is evolving so much, it's moving away from traditional world to machine learning and AI, dependent models. So take for an example, Amazon, right? So how many of you have experienced when you search for a product, you also get related searches, related products, right? So those are all a part of an AI system, right? So these are called recommender systems. So those things existed even before all the terminologies that we're talking about today, right? Be it MCP or be it LLMs or SLMs, LCMs, and all those stuff, right? So AI has been there for many years, starting with reinforcement learning, recommender systems, and all that stuff, right? So now, interestingly, how do you test for recommender systems is another question, and that's where we should really talk about what we as a testers could do about all the applications that we're interacting with these days. It's going to be AI built, right? So the shift reflects a broader transition, and that's what we're going to see about, right? But as I was telling about the testing reality, right? Let's do a quick check, right? So you can actually see the different extremes. So you see traditional automation, and then you see AI assisted way of testing. So let me explain a bit about it, right? So let's talk about traditional automation. I just wrote it saying limited autonomous task performance because we're talking in an AI context, but obviously it has its own pros and cons when we started. But let's talk about early 2000s when automation was picking up. It was all back then functional testing, right? So let's talk about tools from Mercury, which is later QDP, and then Selenium was there, which was mercury cure for mercury poisoning. That's why it was named. So all of those things happen, right? So what happened back then was we wrote scripts that said, click a button, assert that field, and do those tasks. So what really happened is, so we, the humans, the testers, were instructing this is what my test has to do. And then a field changes in the UI, test gets failed. So what happens? We, the humans, the testers, looked at what failed, debug, and then we fix this test. Good, we are having jobs, otherwise we would not have jobs, right? So, and I know the pain of why people think AI might take the job, because that is where the AI-assisted testing spectrum, where the tools like Testim, the Apply tools, all these worlds that you see out there, they said, hey, we will help you make your scripts smarter, right? Whether it being visually validating your tests, or the UI has changed, let me self-heal myself by having a quick DOM snapshot. So all of these things were promised. They did a good job, no complaints. But then, what happened after that? So it's still us humans. We are the ones who are executing it. And AI is being used still as a way of just a good execution engine, that's it, right? So we were not using AI to its fullest extent. And now, thanks to all the things that we have right now. And the actual reality gap, one of the recent surveys conducted by Gartner and all these Everest people, and one of the reports, and even in one of my LinkedIn posts, I recently shared about DORA metrics, like the DORA report from Google, which talked about how much percentage of people are using AI, and how much percentage of that is actually used in production, right? So that's a huge difference. So just to put a number through it to make perspective, so around 85% of people use AI day in, day out. Now, that is to enhance their productivity or whatever it is, whether using Copilot, great, because that's easy, right? So right now, pretty much most of the companies are in Microsoft stack, and you get the Copilot bundle with it, so you use it regardless of your choice, personal choice or not, but something you're getting used to it, so you get a flavor of AI and how you're using it. But then, surprisingly, only 17% of the AI is actually productionized, right? So people are not too confident about, yeah, I'm using it, that's great, but how does it actually making meaningful? Can I put my client's data on it, customer data on it, and all that things are coming up. That's why I'm sure you would have seen post about how AI is helping things as well as creating problems where there is a lot of, lawsuits, and people are, doing for lawsuits about, data breach and all that stuff. So let's be beware of those things as well. But now, coming back to our reality of, the testing world where I spoke about, so surprisingly that this, correlating to the same numbers, 85% of our testing efforts is still spent on maintenance, where no one, we are the ones who are looking at those fixing of tests. The human bottleneck is still there, right? Even if it's test design and strategy and all of that. So the transformative question that I want to ask, or the key takeaway from this particular slide would be is, so here's my question to all of you, right? So what if your test could think? Or what if your automation test is running? When it runs, how cool it will be, it learns if there are new fields, or even if it's new screens, and then automatically suggest new testing scenarios, new fields, right? So it's more like they are collaborating with us, right? So like Copilot programmer, like pair programmer, let's put it that way. So that's where we are thinking, right? So that's where the vision that I want to talk to you about. So let's talk about, a system or a framework, how cool it will be if we build something that, identifies new user flows during testing, that can also adapt and self-heal when something changes, because continuously these days we are changing a lot of stuff in the UI. And then also identify risk. What about the data, if there are any leaks? And then also suggest use cases, right? Like test cases from production data. So a lot of companies are, thinking in that direction as well. But one of the biggest test cases for you would be how a customer would be using, right? For example, it's very easy if you're, I can see, my friends and colleagues, working at, Telstra, Optus, Suncorp, and all these people who are actually, being part of that, application building, but also as a customer. So how a customer goes in and how tested. So when you're stepping in that shoes, how you approach that application, what do you look for. So imagine the same mentality, the same thought process that AI can have. And then what will happen with that power? It can suggest you with that coverage, it can suggest you with the test cases that, hey, it's good you're having this coverage, but you're missing out on those extra cases that you might have not thought about. So those are the things that we're talking about, right? It might sound like a science fiction, but last year when I was researching about it, it felt like, oh, is it doable? But actually it is doable, right? So let's talk about it more. So let's get into AI and talk a bit more about it. And again, for those of you who attended my talk last year, I'm sure this slide would be familiar, where I opened up and showed you about when I talk about AI, when I search about AI, there are so many things coming up. But what is it that's really AI, right? So that's the taxonomy. So telling you about, easily people can relate to applications like ChatGPT and Copilot, but that's not really AI, right? It is part of an AI ecosystem, but where does it actually stand within the complete ecosystem? So that's the slide for you that talks about artificial intelligence, narrow AI, and then, I'm sure you heard about terms like machine learning and deep learning and all this. But in reality, day in, day out, we use ChatGPT and Copilots, and that's where it belongs to. So going further, Agentic AI. So we have been having talks around AI and Agentic AI, even in the same very day conference today. I'm sure you will learn a lot about it. But again, going back to the previous slide and this one, now let's talk about where does Agentic AI really fits in, right? So just to give you that example. So deep learning, again, within deep learning, you have various different things like narrow AI, strong AI, Agentic AI, and all of these things are, just evolving around things. So just to give you, okay, I have a next slide that talks about a bit more examples, but that's just a way to give you where Agentic AI fits in the whole ecosystem. So if you didn't understand, not a problem, but just keep in mind that you saw something like this, so you can actually refer when I talk through, because I have a bit more, and that's what we're going to see every slide from now on that talks about Agentic AI. Now, so generative AI knows how to produce, right? So Agentic AI knows what to do, when, and why. That is the key understanding that I need all of you to have. If someone talks about generative AI, say, or if a rather question comes up with, hey, how many of you have used AI? The smarter question for you to ask back them is, oh, are you meaning generative AI or Agentic AI? And then, you can have meaningful conversations, and that's how, you can give a feeler that you know what you're talking about, right? Be it AI and all that stuff. So we spoke about narrow AI in the first, the previous slide. To just give an example, that's more like a chatbot system. So I'm assuming, some of you are annoyed, right? So back in days where some problem, you pick up a phone, you call, an agent speaks, you get problem solved. So now we have to enter various different things, and you end up in endless texts and chats and all over there. And generative AI, it's for creative, contextual, and output generation, for the likes of ChatGPT and Copilot and all these things that you use to produce content. And a lot of startups have evolved based on these large language models and stuff. And the main thing is agentic, right? So for autonomous, goal-driven planning, and all that learning stuff that we're going to talk about. So what is Agentic AI, right? So it's a shift from asking, what should I do, to declaring, here's what I want to achieve. So based on that, it will help you achieve the goal that you wanted, right? So it's an AI that doesn't respond, but it takes the outputs, learns from it, and persistently work towards your goal. So that's what Agentic AI is really all about. And this is not just a magic concept that started just yesterday or maybe a couple of months ago. It has been there forever, right? So, but it just, the evolution has been there fundamentally from the process automation, a rule-based script, you have process flows, data, automation script, and then you have supervised AI and ML, where you have trained models that could predict and classify still task-specific tasks. I think last year I spoke about how people are using models to detect breast cancer, right? So that's again a part of supervised AI and ML. And then you have Gen AI, which pretty much all of you know. It's the prompt engineering, the NLP, natural language processing, using large and small language models, and then you generate multimodal artifacts. So you can use different. I'm sure all of you tried generating images of yourself. So finally you just give a portrait. I don't want to name the vendors, but you can put it. So just give a portrait, and then you can have a photo shoot in Italy or India, wherever you want to go, whatever And I had a baby 14 months back, and I had a photo that I took in the hospital. So I put it up to Gemini, and it gave actually a decent photo. Even though I did a newborn shoot, it was actually closely relating to what I did. So thinking about what happens to photographers, but again, you will not have an agent take a photo in a real life, so don't worry, photographers still have jobs. That's just to give you an example, right? So with Agentic AI, we have systems that can set goals, plans. You can actually see how the flowchart goes. So fundamentally, what I want to share here is, this is the shift that moves from automation to autonomy, right? So tools that actually means true AI. So now we spoke about Agentic AI, but there is also something called agents, right? So this is something that I spoke in Sydney as well. I don't know how many of you attended my talk in Sydney. The title was more around AI agents, the rise of AI agents and Agentic AI. So it's closely resembling, and it's a fine line between these both, and people often get confused about what is AI agents and what is Agentic AI, right? So I just put it down easily, where it says an AI agent is like a kitchen appliance. It could be a blender, toaster, but an Agentic AI is more like a personal chef. If you want, hey, I'm on a keto diet, I want a food that is based following keto and all that stuff, or if I want a gluten, give me a healthy meal that's gluten-free. So the chef knows what are the ingredients they should do, how you should plan if you have if you're on a calorie deficit, if you say this is much calorie I want to have. So all these things can be understood, learned, and the chef can prepare, right? So imagine all of this is done in a programmatic way. That's where AI agents come in, right? So just to put it easily, you have kitchen appliance versus personal chef. Or to put it in a more plain text, I would say AI agents is more like a task executor, whereas Agentic AI is more like a goal achiever, right? So the distinction is, how do I do this specific task? AI agent. The Agentic AI would be a goal achiever. So what needs to be done to achieve this goal? So, and then how AI agents work and how Agentic AI works. So that's the distinction that I've shown in this slide, where AI agents perceive, they understand the reason they act, and then some agents learn, some agents do not learn. And there are different patterns about building agents as well. That's another topic for another day. But from an Agentic AI perspective, it collaborates, it coordinates, it adapts, continuously learn, and then finally achieves the goal for you. And it might not achieve the goal at the first stage, but it evolves and learns, right? So that's where the distinction of AI agents and Agentic AI helps. So just a quick check. Whatever we have discussed now, does it make sense? Yeah? Okay, cool. Now, what makes AI agent really agentic, right? So that's what we're going to see. Now, we have to unpack Agentic AI. I'm sure to tell you this slide will be a little bit interesting. Even in Sydney, quite a few people came back and asked us questions about, oh yeah, Agentic AI, I've seen this everywhere, but what it really, I don't know, right? So even if you Google Agentic AI, you get tons of vendor products, you get tons of tutorials and blogs, but it's really, very hard to understand. Thanks to these generative models, so you can actually prompt it well enough, it will give you the result that you wanted. But making your life easy, so I'll show you how Agentic AI, AI agent becomes an agentic, right? So let's get. Cool. So if you want photos, please take it. So the core concepts, so that's where it talks from. So it has many different things: Agentic AI, core concepts, agent types, architectural components, application domain coordination. So all of this combined together is called as an Agentic AI. Simple as that. So in core concepts, we are talking about traits like autonomy, proactiveness, persistence, and this is what the agent gets their intelligence from, right? So under agent types, we see different flavors like reactive agents, learning agents, hybrid agents, and all of this type, and then coordination models that define how agents interact, the chain of thought, the reason, getting it more collaborative, and then the architectural components, like the planners and executives, and finally the application domain, like where it's being used. It could be used in a software, a QA processes. It could be used in customer support, like the chatbots, in DevOps and accessibility, in all of this sorts, right? And moving on. So now, how does all work together? Sort of I showed in the previous slide, but just simple 4-step process, right? So plan, execute, reflect, and refine. So that's the fundamentals of how agentic AI really works, right? So that's the fundamental concepts of any AI or agentic frameworks that you see out there in the world, including many of the vendors that are here with us on the floor. So that's where it stands. Now, smart agents are great, but what if they don't have an idea of what they are talking about? Because we say large language model exists. It's been trained with billions of data, millions of data, and all of that. But what if it doesn't have the data that what you wanted, right? So that's where things, right? So that's where RAG as a concept that comes into picture. It's called retrieval augmented generation. So how many of you have heard that term before? Great. Only about 10-15%. For those of you who didn't know, you have large language models like Mistral, DeepSeek, Claude, all of these. So they have been trained with billions of data. We don't know where they get from. So it is there, exists. And sometimes we can ask a specific question, and it didn't know the answer. So that's where the knowledge enhanced LLMs comes into picture. Where you incorporate knowledge into LLM that can actually learn from it and give you a more relevant data. So imagine you chat with LLM, ask a question. It may not have that answer, but you give your contextual data so that you get actually a better results. So let's see some RAG in action, which I had it for a demo today. So quite early on in a demo, isn't it? We'll see how this works. All right, so hopefully the demo gods is with me. All right, cool. So I'm going to ask a question, say, who are the speakers at Testing Talks 2025? Excuse the typo. I'm just seeing the screen is actually extended. So great, I'm sorry, but I don't have access to real-time data, right? Because whatever LLM that you're chatting with, it has been released periodically. So only until then it has access to that data. But sometimes, yeah, it will be interesting because these days people are not using Google anymore. They're using ChatGPTs and Copilots. I don't know how much true it is, but sometimes I do too. I'm sure most of you do that as well. But if you quickly wanted to see, I'm too lazy to open up Testing Talks, click on agenda and all of that stuff. You ask this question, I didn't have data. So now let's do one thing, right? So let's click on use RAG, and you can actually upload a file. I just went to the page, like Testing Talks, and I just did a print page. So it has access to all the speakers, right? Open. So then I give process documents. Boom, there you go. So that's how RAG works. Sometimes you may need answers that are specific to your needs. And especially coming into corporate and enterprise world, it's even more terrible because these data is not good enough for what we need, and that's where RAG as a concept comes into picture. Or rather, if I want to go crazy and I can ask who is Manoj Kumar in Google. It's a typo. Okay. Sorry?
They can do testing.
Yeah. Let's see what happens if I refresh once, come back, and make sure who is okay. Obviously, I'm not a founder or a CEO. Okay. I don't want to yell at bat saying I don't know who the guy is. So. Let me add more contextual data. So I'm just giving an about me page. So here's my story. So if you go to manojkk.com, that's my personal website. So it has everything that about my profile and portfolio. So I just gave open and then I process documents. It does the same thing, right? So documents processed. So yeah, this is exactly the kind of result that I wanted. But obviously, I don't have the powers to train the model. I'm not a data scientist. I don't have a machine that that can train a billion parameters. But that's how really you can make RAG difference works. So that's pretty much. This is a simple prototype app that I built. Just want to show you on that. So hopefully that made sense. So let me go back to my slide. Okay. I think I should go back and keep doing this because I was very excited. I did probably one demo in Sydney, but I'm gonna do 3 demos here. Isn't it that exciting? Do you want 3, 2, 1? Okay, right. So even in RAG, there are multiple things, right? So that's how tech world welcomes us with plethora of data and knowledge that we want to learn from. So there is RAG. And then there is agentic RAG as well. So what's the difference? Obviously, RAG is static information retrieval. It helps you grab the data and gives you answer. But with an agentic AI, it's different world. I just leave it there with that data. It autonomously decides, how to retrieve, what document to retrieve, right? So I know my question. I asked who is Manoj Kumar, and I gave an about me page. I know this is the PDF that I want to send in. So imagine if I gave a PDF that is with someone's name on it. I can see David, so I can just give David's name on it. David's about me page. Obviously, you get confused and not give it the data, right? So that's how really things work. But in agentic world, agentic RAG really knows to know which document to pick, right? So that's how things evolved. Now, how does this flow happens, right? So when you hear about agentic AI spectrum, people always think it's autonomous, but that's not the case, right? So if you really see, you can actually build an agentic AI system that's fully controlled to fully autonomous as well, right? So you can, if you really see, that end of the spectrum is fully autonomous, and this one, is just like prompt chaining. You can send one prompt by prompt and have a fully controlled system to have an agentic flow, and then have a semi-autonomous agentic flow. You can put examples to various different things. But end of the day, that's where the human in the loop as a concept comes into picture, where if you know the agentic AI system really works from end to end, then you can have it fully autonomous. But if you're not confident, if you need to have a human review in every process, so that's where the semi-autonomous agent comes into picture, so you can have a human in the loop review as much as possible. Now, where are we going with that? We did manual testing. We did test automation. We did some AI-assisted testing. Now, agentic AI testing is going to happen, right? So that is where we're going to look into it. So what does agentic AI brings to quality? What are we going to do? So my thought process is we're going to be writing tests. We were writing tests to going to be defining goals, maintaining scripts to guiding agents, from a reactive debugging to proactive risk management, and isolated testing to collaborative intelligence. So that is where I see it's moving, and I can already see it's moving. If you talk to real tech companies who do agentic AI, like completely from the scratch to production, they are actually doing that, right? So most of them, of course, everything comes with some sort of a human in the loop review, but the remaining time they do productively spend more time on exploratory testing, more domain-specific checks, and all of that stuff. Now, agentic AI capabilities, what it can really do. How are you so confident in that telling? You'll be moving away from writing tests to writing goals, right? So these agents can do multiple things, right from intelligent test generation to, that can create tests from requirements to adjust to application changes. We talk about self-healing, and self-healing is not really a new concept. It has been there for a couple of years now. And then you talk about fixing broken tests automatically, not self-healing alone, but more than that. Risk-based prioritization, risk-based testing. I know risk-based testing is one of the key concepts that we have been using it, but if you power that with agent, it actually gives a lot more meaningful results. So now continuous learning, right? All of this learns like you, right? How we learn from every process. Agentic AI also learns from all of this, obviously, which means it is getting knowledge. So will we see a world like Terminator, the movie? We don't know. That's where the applied artificial intelligence, that is still theoretical, but we don't know when we can see it in action. But I'm sure there will be some robots already in the world of China and Japan, so who knows. Funnily enough, I saw reels in Instagram that spoke about, that a humanoid robot was just walking and then it bumped into a human and then started boxing. I don't know how many of you saw, but things like that still happens to you. So, all right, finally, that's about it. So now we spoke about agentic AI, how it evolved and what it entails. So now let's see what really powers that agentic AI, right? So if you're key, okay, Manoj, we know agentic AI. You told me about what is AI agents, what is agentic AI, and what it is capable of doing, right? Obviously, the umbrella that I showed is just like some of them, but the possibilities are endless, right? But then when you put all these agents together, so this is how it works, right? So every agent or any agentic framework, this is how deep down it works. So it usually has, it's more like a multiple agents to a super agent. Let's call it that way to make it simple. So if you unpack it, it has orchestrator agent, it has learning agent, specialist agents, communication layer, and all of this, right? So and as you see, specialist agents serve as domain experts. And I know early in the day, Ravi covered about accessibility agent and all of this in his framework. So you can actually build specialist agents for yourself, and then also a learning agent that's job is only to see a data that is coming from LLM, a human approves or denies it, or if human denies it, what is the feedback? So all of this is learning, right? So you can actually have an agent that sorts of learn all from this and then evolve every time. So when you ask a question at the first time, the results that you're getting will not be the same as the one that gets 100th time, because it's continuously evolving, the results will be much better. Again, it's probabilistic, so that's where the testing really has to evolve there. So let's build one together quickly. I don't know how much time we have left, but let's pick a classical scenario that we have, right? So user story to BDD Gherkin format. So now, in the previous slide, we spoke about different agents, correct? The unpacking of how the agent itself works. And now, open question to all of you. So if you were to build an agent that converts automatically user story to BDD, what are the different agents would you build? Don't tell I can do in ChatGPT. So if you still say that, I wonder what you did for 30 minutes. I've been talking about agentic AI. So don't worry, I'll not be rude that much. But so any thoughts? What sort of agents would you build to convert your user story or test cases into BDD? RAG, yeah, okay. Because you give more context. Sorry? Perfect. Did you attend my Sydney talk? No. Did you attend my Sydney talk? No, right? Okay. Obviously, analyze requirements is a good thing to do. What else? Yeah? Yeah, okay, yeah. We could add that. NLP in what way? Yeah, it's more like analyze requirements. But so we are talking about analyzing requirements. What sort of steps would you do to build? So NLP is a concept that actually analyzes requirements. So upload document, that's like the RAG concept. Generate test data, yeah, makes sense. Yeah, you can have all different agents, right? So let me show you. So you can actually have user story analyzer itself. So we know whatever user story we look at every day is not in the best shape. So obviously we need to go and have a chat to product owner and solution designers to understand, does it really convey what it needs to do? Because I have tons of questions. So first thing I would do is to build a user story analyzer. And then I would go ahead with, okay, I think I need to be a little closer. Test scenario generator, agent that generate test scenarios based on the requirements and the analyzing from the user story, and then BDD generator itself. And then end of the day, I also want to do something like review an agent itself, right? Does that make sense? Am I, yeah? So now, what do I need to build this? Let's quickly see. That is all really you need. So here are the tools that I would use to build user stories that can convert into Gherkin scenarios. There are too many things, Manoj. You made my life tough. I would very well use Copilot or ChatGPT. Well, yeah. If everything in the life was that easy, then it'll be a different world, isn't it? Parallel and multiverse. All right, so I mean, in a way, these are the concepts that you would need as well to build that toolkit. So let's start from prompt engineering and testing, right? So you need to tell what that agent needs to do. For example, you need to give the roles and responsibilities of that particular agent. That will be in the form of prompt engineering, right? Because user story analyzer, if you were to put a prompt engineering on that, what would you do? You would say, hey, you are a BA SME, you should act as a user story analyzer. Your job is to use all the rules, how the user story should be, and then do that. So how many of you know INVEST in Agile Manifesto? That stands for, INVEST is a framework that Agile Manifesto codes that every user story should follow that INVEST principles. So INVEST is nothing but independent, negotiable, valuable, estimatable, testable. Thank you for completing it. I had a little brain fade moment. So yeah, so and not every day the SMEs check with that framework. So agent will help us validate that. Now framework and agent runtime. So there are tools like LangGraph and LangChain. I'm going to use that as well. I'll talk a bit about it. In short, you can actually think LangGraph and LangChain are the ones that's more like the Selenium or the Cypress world that help you build tests. I'll actually take questions at the end because I'm really running short of time. And Cam just waves me 5 minutes. Did you actually count in for the minutes that I lost in the beginning?
For 3, and I don't want to keep people from a feed, so we'll try wrap it up in the next few minutes, mate.
Okay, cheers.
Thanks, mate. Appreciate it.
All right. So and then you have memory management, vector DB, all this stuff starting from LLM provider, OpenAI. You can use any LLM provider that you want, and then from a test automation perspective, you can actually build a Gherkin Parser, whether it's follow Selenium Playwright or Cucumber, and then from an environment perspective, you can use Python or Node.js. That's what these frameworks do. Let's see it in action. Okay. I did various different things. Okay, let me start the UI. And I start the backend. Right, so that's a simple utility that I built in my spare time, the time that I should be spending with my family or the kids. But anyway, they're used to it. So insurance code, you can actually have different things. So let me just use a user login. It has a sample user story. Just for simplicity purposes, just me remove this and this run, start a live conversation. So this is like you actually have various different agents. So the different agents that I showed you in the previous slide are the agents that is actually in action. So I already have a user story analyzer that sort of analyzes. So this is actually working in production. So I have an actual Claude API that I hooked up. So it's actually talking to LLM coming back. So it may be a little bit slow, but while that happens, I'll actually talk through the story analysis and agent that actually can actually see 4 actors, 8 actions, and 6 rules. So it knows how to decide how many actors are there in that particular user story and how I should define my criteria. And then the scenario generation itself sort of generates that. And the translation actually, you can actually see there are total 89 total steps. And then finally, I'm actually doing a quick check of myself, right? So there you go. It shows about, it's too confident, says 100% coverage, but that's debatable. But anyway, and it says quality medium. So yeah, that's where I need to improve the agentic framework itself. So for a user login feature, there you go. It actually gives you the neat background, happy path, critical edge flow, negative workflow, and all of this. Right? Trust me, if you have to write this, I've been there, you've been there. It will take us at least quite a few hours to build this. So even if it's a more enterprisey user story with a lot of acceptance criteria coming in, there will be a lot of things that you'll be doing as well. So that's the quick one I had. And the other one that I had to show you was Jupyter Notebooks. That's another way to quickly do it. Just to say quickly, right? How many lines of code to build an agent? Just 4 lines of code. So you really need just 4 lines of code to build an agent. That's it. But no one simplifies that easily for you, right? So, but here I am, trying my best. So if you see, ignore the print statement. Let's look at the scenario generator node. Let's ignore the print statement. Start with analysis. That actually takes the output from the previous one because we are talking about scenario generation. So you actually saw scenario was the second step, but the analysis was already done. So it actually takes the output from the previous step, and then it has a prompt. So it actually has a 2 set of prompts. One is a system prompt and a human prompt. System prompt is actually where you put the prompt engineering concept saying, hey, you are an amazing SME with so much of years of experience. So you review this as a business SME and all of that data. And then you have chain prompt. You pipe that to LLM. And then you send that response, and then chain.invoke is actually the function that uses the LangChains function to build it. So that's it. So this 4 lines of code is actually building an agent. So, and this is how I extended the framework that I showed you previously, where it talks about how you can actually convert user story to BDD. But obviously in Sydney, I had an opportunity to run through, but it's the same thing using LangGraph, and it actually gives you all the results as well. So scenario 1, 2, 3, and then you have Gherkin file and all of that. So this is just in 4 lines of code for each agent. But what I showed you previously was an entire actual agentic framework that you can actually implement in any enterprise for that matter, with RAG enabled and all that stuff, right? So to quickly finish things off, since we are running short of time. So we saw in action reference architecture. Again, just quickly skip this. If you want to do, this is how I would tell you to do it. So pick a use case. We picked user story to BDD, but you could pick anything else, and then choose an LLM approved, whether whatever is in your enterprise, and then you need prompt engineering techniques to tell what sort of prompts. Again, remember, an agent is just 4 lines of code, right? That's what I understood. So don't quote me anywhere, but you can. So don't worry. I'm just kidding, because you saw it in action. It works, right? So. And then RAG, and then of course you need AI guardrails, and then you evaluate, and then you tune and execute, right? Well, not many people talk about challenges. What we all saw was great, but then it obviously comes with some challenges as well, because you need to see what sort of results that it comes back with, the concurrency, the bias, where does it reference the data from, all of those data. So all of these things might slow you down, but again, it's for a greater good, because you'll be confident that you're actually building things that you can actually really test for. Right. That's my closing thought. We're not just accelerating automation, we are architecting the intelligence in the heart of QA. For those of people who don't know me, I'm Manoj Kumar. I right now work at Cognizant Australia. I'm a huge open source fan. I've been part of various different frameworks. Selenium is obviously one, being the major, but I've been part of Protractor, Appium. I also have my own frameworks on Kubernetes, Selenium, observability in Selenium, and all of this. And I like accessibility in DevOps. Right, if you want to connect with me, please connect with me, very much happy. And thank you so much for attending this talk. Hopefully you got a thing or two. Happy to have any conversation about what we just spoke or anything else that you saw about me. So yeah, feel free. Thank you so much.
Fantastic, Manish.